Welcome to ACE Assert. In this video, we will be discussing practice exam questions for Google Professional Machine Learning Engineer Certification Exam. Question 1. Your team is building an application for a global bank that will be used by millions of customers. You built a forecasting model that predicts customers' account balances 3 days in the future. Your team will use the results in a new feature that will notify users when their account balance is likely to drop below $25. How should you serve your predictions? A1. Create a pub subtopic for each user. 2. Deploy a cloud function that sends a notification when your model predicts that a user's account balance will drop below the $25 threshold. B.1. Create a pub subtopic for each user. 2. Deploy an application on the App Engine standard environment that sends a notification when your model predicts that a user's account balance will drop below the $25 threshold. C.1. Build a notification system on Firebase. 2. Register each user with a user ID on the Firebase Cloud Messaging server, which sends a notification when the average of all account balance predictions drops below the $25 threshold. D.1. Build a notification system on Firebase. 2. Register each user with a user ID on the Firebase Cloud Messaging server, which sends a notification when your model predicts that a user's account balance will drop below the $25 threshold. The correct answer is D. Firebase, specifically Firebase Cloud Messaging, FCM, is the ideal solution. It scales for millions of users and allows direct personalized notifications. Here's why the others miss the mark. Options A and B, using individual pub subtopics, create unmanageable complexity. Option C's average-based notification doesn't meet the requirement for individual alerts. Firebase is the best option for mass notifications. Essentially, Firebase provides the necessary scalability and targeted messaging. Question 2. You work for an advertising company and want to understand the effectiveness of your company's latest advertising campaign. You have streamed 500 MB of campaign data into BigQuery. You want to query the table and then manipulate the results of that query with a Pandas data frame in an AI platform notebook. What should you do? A. Use AI platform notebook's BigQuery Cell Magic to query the data and ingest the results as a Pandas data frame. B. Export your table as a CSV file from BigQuery to Google Drive and use the Google Drive API to ingest the file into your notebook instance. C. Download your table from BigQuery as a local CSV file and upload it to your AI platform notebook instance. Use pandas.read CSV to ingest he file as a Pandas data frame. D. From a bash cell in your AI platform notebook, use the bqextract command to export the table as a CSV file to cloud storage, and then use gsutilcp to copy the data into the notebook. Use pandas.read.csv to ingest the file as a Pandas data frame. The correct answer is A. AI Platform Notebook's BigQuery Cell Magic directly integrates BigQuery data into Pandas data frames. Why avoid the others? B, C, and D introduce unnecessary data export and transfer steps. The Cell Magic simplifies the data import. The Cell Magic provides the most efficient, direct data transfer. Question 3. You are an ML engineer at a global car manufacturer. You need to build an ML model to predict car sales in different cities around the world. Which features or feature crosses should you use to train city-specific relationships between car type and number of sales? A. The individual features, binned latitude, binned longitude, and one hot encoded car type. B. One feature obtained as an element-wise product between latitude, longitude, and car type. C. One feature obtained as an element-wise product between binned latitude, binned longitude, and one hot encoded car type. D2 feature crosses as an element-wise product. The first between binned latitude and one hot encoded car type, and the second between binned longitude and one hot encoded car type. The correct choice is C. The element-wise product of binned latitude, binned longitude, and one hot encoded car type captures vital location car preference interactions. Why the alternatives fall short? A. Individual features fail to capture interaction. B. Raw coordinates hinder geographic pattern learning. D. Does not capture all three features at the same time. The combination of all three features allows for the most complex learning. This feature cross enables the model to learn complex, localized sales patterns. For a full list of practice questions, drop an email at acert6@gmail.com. Thanks for watching.